Hey everyone, it's David with Streaming Relativity, home of the Astro DNA Observatory. Okay, so I love astronomy, I love astrophotography, and I have my, let's say, my favorite types of targets to image. They happen to be wide field galactic targets. You may have your own, and I certainly enjoy other types of targets, but I'm partial to galaxy images. And when I talk about wide field, I'm talking about images that could be those deep field images that we see from Hubble or from the Webb Space Telescope, but they can also be images that you capture in your backyard, like this one of NGC 1275, which is obviously Perseus A, so it's in the Perseus constellation. And I cover how I captured and processed this this image in the sights and sounds of a supermassive black hole. If you haven't seen that video, you should check it out. But wide field galactic targets often include galaxy groupings, some gravitationally bound, some just visually associated with each other. But typically this is where we have larger appearing galaxies in the foreground. And a good example of that would be NGC 7331, which I think I covered in a video called Our Cosmic Twin. And then you have cases where you have both these large appearing foreground galaxies, yet we have a deep field of smaller speckled galaxies, and those are super awesome. And in fact, in our video today, we're going to be speaking about what I think to be a fabulous target, which is the Leo Triplet, which is an amazing grouping, gravitationally bound grouping of galaxies in the constellation Leo, but it also has an amazing deep field background that I think many people overlook because of the enchanting interactions that we see between the three foreground galaxies. So if you've never imaged the Leo triplet, you are absolutely missing out on one of the best galactic targets out there. And in this video, we'll show how you can locate this target, how you can capture it. I'll do a high level on the processing, and most importantly, we'll take a tour of the image and we'll appreciate why the Leo triplet is so special. And with that, if you're into astronomy and all things astrophotography and you like this kind of content, go ahead, subscribe. You won't regret it because there's content coming out every week, and this is simply the best way for you to get notified. And with that, why don't we do a deep dive into the Leo triplet? Okay, as the name implies, the Leo triplet is a grouping of three galaxies in the constellation of Leo. It's also known as the M66 group because M66 is the brightest member of this trio, and the other members, of course, are M65 and NGC 3628. And that's listed in the order of their magnitude or their apparent brightness to us in the night sky. To find this grouping, you're going to start by locating Leo, and that is relatively easy because I think Leo is a highly recognizable constellation. However, not everybody is familiar with the night sky, and you might need a little bit of assistance here. So this is a springtime target, and at least it is in the northern hemisphere where I observe an image from. So I often use the twin stars of Gemini, so that'd be Castor and Pollux, as my kind of orientation. I begin by locating those stars, and then from there we can start to move east. And as we move east from the constellation Gemini, we're going to cross through the Crab or Cancer constellation, and then we will eventually next reach the beginning of the Leo constellation. Now, you're at Leo when you see this kind of reverse question mark or the sickle. That marks the head of the lion that Leo is. And there's a bright star called Regulus, and that bright star in that reverse question mark or that sickle, that marks the heart of the lion, which is the chest of the lion. Now, if you continue to the east, you're going to find another bright star, which is the nebula. And that happens to mark the tail of the constellation. And between the chest and the tail, you're going to see the body, and then you'll start to see the legs of the lion. And so hopefully that little bit of orientation will make it easy for you to visually spot Leo in the night sky. Now, the Leo Triplet is a deep sky object that is located in the right rear paw of the lion, and so you'll be able to spot it with binoculars if you have binoculars, if you're scanning that area, and certainly with a wide field small refractor, 60 millimeter, 50 millimeter even, you'll be able to make out this dark sky object, these three galaxies. So if we dig a little bit deeper in, what are you looking for? You'll be looking for these three smudges that are relatively close to each other in terms of angular distance, and each is a galaxy that presents at a different angle. So, and we'll talk more about that in a moment, but because of these angles, we get to observe features of the morphology of these galaxies, and we can conclude that there has been some recent interaction between them, perhaps as early as 800 million years ago, and so they're gravitationally bound to each other, and they are interacting, and that evidence is going to be shown when we actually tour the image in just a bit. I will point out one other thing, that the triplet may in fact be a quad. There is another galaxy, NGC 3593, which I'm not going to cover in today's video, but will be the subject of a future video. It happens to be a lenticular starburst galaxy, which is a very interesting topic, and we'll image and we'll talk about that galaxy in a different video. Okay, so I used my Astro Tech 115 EDT refractor telescope to capture this image, and I think it happens to be the perfect focal length for the story that I wanted to tell here, and that focal length being, of course, 644 millimeters after the 0.8 reducer field flattener. You'll be using that with this telescope for most of your imaging, and I happen to pair this telescope with my ZWO ASI 2600 Pro monochrome camera. So I use filters with this, and I achieve a field of view of roughly, let's call it 2 degrees wide by 1.5 degrees tall, and that field of view allows me to showcase not only these three foreground galaxies, but allows me to capture a lot of the deep field objects, deep field galaxies that most people, I think, just overlook when they're imaging this target. So I ran my sequence on April 7th and 2024. Now that's the night before the eclipse. We were very lucky because clear skies were coming in. I had my fingers crossed that was going to carry over into the 8th, and that I was going to get a good eclipse sequence with this telescope. And I did manage a sequence, and that's a different video. But I ran from about 8:15 p.m. on the 7th to around 3:30 in the morning, and I was blessed with clear skies, and I had no equipment malfunctions. I had no surprises, no moonshine to talk of. And, because my seeing was very good and I was able to run the sequence for many hours, roughly 6 hours of total integration time across my broadband filters, my luminance, my R, my G, and my B, I got some really good data. And I shoot broadband with this rig at a gain of 0 and an offset of 50 for those that are interested. And I was able to gather roughly 45 frames of each the LRGB channels using 2-minute exposures, again, gain of 0, offset of 50. And I'm very pleased with the outcome, and it has made a very nice entry into my astrophotography journal. So let's take a tour of this image and see what we can find and learn about this target. So clearly, this is a triplet, and when we throw the annotations on, we can see which galaxy is which. And more importantly, with a little bit of close-up, we can start to talk about the morphology or the shape of each of these galaxies. Galaxies are classified based on morphology, which is their visual appearance. And so let's start with M66, the namesake for the triplet. It's also known as NGC 3627 and PGC 34695. We'll see why I introduced PGC in a little bit. So this is the brightest of the group. It's a magnitude of 8.9, and it is an intermediate spiral galaxy, and it was discovered by Charles Messier in 1780. Now, intermediate spiral galaxies, when we classify galaxies by morphology, and I will do a separate video on this, there are branches. Once we go past elliptical and lenticulars, we get into this notion of spirals, and the spirals themselves can fall into three different classes. And this happens to be intermediate. There is also just an armed galaxy, and then there's a barred galaxy. So intermediates are in between. So like spiral galaxies have these kind of rounded, symmetrical round cores, and then the arms that branch off from them. And then barred galaxies have, you can see, a more rectangular core before the arms develop, and then intermediates are somewhere in between. So the specific classification of M66 is SABB, which means that it has spiral arms that are not too loose, but not really tight either. And let's just call it's a middle of the road tightness in terms of the arms, the spiral arms themselves. And you can see the bar shaping in the core of M66, and you can see that the arms themselves are kind of fraying a little bit, and you can even detect a little bit of discontinuity in the dust lanes, and that is our first clue that it has interacted with one or both of the other galaxies in the group. So M66 is about 31 million light years away, and here we can compare a close-up of this capture, which again is with a 4.5-inch refractor, to that of an image that was gathered with an 8.2 meter scope that was attached to the FORS 1 and FORS 2 instruments. And yeah, of course, their image is much better, but fundamentally, the fundamentals of both of these images are the same in terms of the morphology and evidence of evolution, and so they're equally accessible. And I think it's pretty impressive that we can see this with such a small telescope. Okay, so let's scoot on over to M65, another intermediate spiral that was also discovered by Charles Messier in 1780, and it's a little tougher to make out the bar shape within the core of this. That's in part because of the angle of viewing. It's a different angle. It's more oblique than the angle that we saw in M66, but we do see that around the core it's very diffuse and very low in dust and gas. In fact, there's very little evidence of star formation surrounding the core, and most of that is happening far out on the edges of the galaxy. And so the ratio of old stars to new stars is quite high in this galaxy. Now, this galaxy M65 is an SAB RSB classification, where the RS indicates that it has a ring feature, that which you can clearly see, by the way, in our 4.5-inch refractor capture, but it becomes even more obvious when we take a look at this capture from a 32-inch RC telescope at Mount Lemmon Observatory in Arizona. And you can see in both images that there are two spiral arms that actually form that ring around the galaxy. And we can also see that that's where all the dust and molecular gases, and there is evidence of star formation happening in this outer ring. And some say you can detect a little bit of a warp in the disk, again, this being evidence of gravitational interactions between M65 and its two neighboring galaxies in the group. Okay, so let's talk about the other neighbor in this trio, and that would be NGC 3628, which is better known as the Hamburger Galaxy. And this is just such a cool galaxy to image because it's edge on, and it looks like a hamburger. And it has this long equatorial band of dust, and that, of course, is going to obscure our view of the core. And because of that, I think at least it's officially classified as an unbarred spiral, so an SA little b galaxy. It's about 35 million light years away from us. But I think it got its classification of SA little b, SA, the SA portion of it, because of this obscured kind of view that we ultimately do not have of the core. And if we were able to view the core face on, we would know whether or not it's barred or not. But there have been some studies that were done in the around 2016 or so, which makes a case that even from an edge-on view, we can see that the core has a bit of an X shape, suggesting perhaps we're looking face on at the bar of this core, and we know that barring, at least we know from simulations, that barred cores are generally an indication of interaction between two galaxies. And since we have evidence that M66 and M65 have had galactic interactions, it's reasonable to believe that so has the Hamburger Galaxy, and that increases the possibility that this is actually a barred spiral as opposed to simply a spiral. But at any rate, we can also see that even in this very small aperture grab, that there is evidence of galactic interactions beyond the X in the core. We know that through spectroscopic studies that the stars inside of this galaxy are rotating in the opposite direction of the general molecular dust clouds. And that can only happen due to some kind of massive interaction that took place with this galaxy. And then finally, probably the telltale sign, no pun intended, is that this galaxy has a tidal tail that extends almost 300,000 light years, and that's off into the north and west of the galaxy. Now, that is not evident in this grab, because it would require some additional data, but it is evident in a number of other fantastic grabs that I have seen of this target. And minus the tail, this galaxy is about 100,000 light years wide, which is about the size of our own Milky Way galaxy. And interestingly, if you look a little bit closer here, you will notice that NGC 3628 has a diffuse satellite galaxy, and that's indicated with that little smudge right here. But there's also evidence of lots of globular clusters around the galaxy, and that's kind of not like very different than our own galaxy, which I think is pretty cool. So, and this I think is a really good jump point to start talking about deep field. And I think it's best to set perspective and scale. And to do that, there are several large, bright foreground stars in this frame. And of course, these are in our galaxy, and they're in the constellation of Leo. But they range in distance from, let's call it, 100 light years to perhaps as much as 500 light years away. So relative to the triplet of galaxies, they're really close. There's a big difference between 100 light years and 35 million light years. And that explains why these stars are so bright and large relative to, let's say, the cores of even the cores of these galaxies. In fact, you could say that they're fairly close to the same size as the cores of these galaxies. Now, if you look at the deep field galaxies themselves that are here, these stars are absolutely enormous in comparison to those galaxies. In fact, most casual observers of this image wouldn't even see the other galaxies in the frame. How many do you see, for example, when you look at this? Well, when I did my estimate, but obviously I knew there were quite a few. I could see them immediately, but I kind of estimated there was well over 100 additional galaxies in this frame. And of course, what I did is I plate solved and created an annotation overlay. And with that overlay on top of the image, you can see that there are close to 100 annotated objects, deep field objects in this image. But this annotation doesn't get them all. There are many more. There's at least this probably got 70% of the ones that are clearly visible to me. So there's a bunch more in here. And, what I like about the annotation is that it helps, especially the uninitiated, those who have not done this exercise before. It helps you to differentiate between what is a deep sky object, a galaxy, a distant galaxy, versus, say, a small foreground star. So, okay, let's go ahead. Let's pan zoom throughout this image and and I'll turn the annotations on and off. That way you can start to train yourself to identify galaxies on your own. Okay, let's call that a wrap on the video. I hope you enjoyed it. I enjoyed creating it. And if you did, and you like astronomy and all things astrophotography, don't forget to subscribe. It'll keep you notified when new content comes out on the channel, and it'll keep me motivated to share my experiences in this incredible hobby. And for those that are attending 2024 NEAF conference next week, or the imaging conference right before it, I will be there. I will be attending sessions, and I will be pitching a hand, lending a helping hand to other club members to help ensure that the conference runs as smoothly as possible. So if you see me, definitely come reach out to me, shake my hand. I love meeting other astronomers, and I hope to see you there. And if I don't see you there, I will see you on the next video.